Let's go with it. Hey YouTube, how you guys doing today? My beard is gray and my name is Trey. Today we're here with another AWS Cloud Quest video in our series, right? AWS Cloud Quest Solutions Architect Associate, right? Now, today we're going to talk about a topic which is container services, right? Something that's very near and dear to my heart. Now, when I do these videos, right, I don't want to just give you the answers like click on this, this is the solution. No, I want to actually tell you about what's going on so that will help you in your journey to one day become a cloud engineer, right? This is awesome. Okay, let's do it. Now, I've put together just a small example to show you what containerization is about if you have no idea, right? We're going to use a small example. So in order to understand like containerization, right, you have to understand the term microservices. So you have monolithic, which means one, and then you have microservices. We're not going to go through this. I'm just going to show you an example, and what better example to show you than Amazon.com, right? So now, a monolithic application, that's an application that's built in one code base. So means, right, if you were to just like build this whole entire website using like, let's say Python, the code language Python, because everybody knows Python, right? If one part of this application crashed, that means the entire application would crash. Here comes in containerization. So what you can do with containerization is you can break up this website into small little pieces, right? So for instance, you come to the landing page, right? You have the front end. You have the UI. Like for those of y'all that have done other videos in this series, you've seen the term, you've seen the little acronym UI a bunch of times. It just means user interface. How do users interact with the specific interface, right? So when you come here, if I clicked on this, right, then this product would come up. And then that's one part of the application, right? Now, if I came here, you know, the application is broke down into smaller sections, right? Then you also have like when you buy something, if I got ready to buy something, I would add it to a cart. That is another function of this application, right? You have a cart that you can put things in. Then you have another function of the application, which would be when you buy something, right? That's a whole nother function that happens. So when you use containerization, right, with microservices, like one part of the application can be written in Python. The other part of the application can be written in Java. One part of the application can be written in the Go language, right? It's just so many things you can do. And let's say that the pricing, right, when you get ready to buy something, let's say that part of the application is broken. The other part, the other entire website is not affected because it's just that one part of the application that is down. So developers will go in, do whatever they can as fast as they can to fix the application. Thus, that is what containerization is about in a nutshell. Very small example. So let's go ahead and get started today. If you have not done so, please click like on the video, share with other people, right, so they can learn about cloud computing, and subscribe to the channel to see more about cloud computing topics for beginners, right? So this is our solution for today, right? So we have a customer. Customer says, welcome to the finest media research center in the city. Thank you for meeting with us today, right? I'm glad to be here. How can I be of service? We've recently decided to launch some key application bundles in Docker containers, and we want to be able to store, manage, and share our Docker images. We would also want to be sure we are as fast and efficient as possible when dealing with our services. Well, AWS is definitely the place to deploy containers. You can host your containerized applications in Amazon Elastic Container Service or ECS. You can store your images in Amazon Elastic Container Registry or Amazon ECR, right? Managing containers through automation is important. Do you plan to manage the orchestration of your container applications? That's a great question. Some of our teams have the technical knowledge to orchestrate their containers. Other teams don't want that level of effort and prefer a simpler management. Well, I have some good news. Using AWS Fargate, right, serverless, AWS Fargate, you don't need to provision servers, and you pay only for the resources that your application uses. This sounds perfect. I would love to see these applications deployed as soon as possible using these technologies. Can you help our researchers deploy their containerized applications? I accept. Thanks for helping our researchers improve the lives of our citizens. And now we'll go ahead and get started, right? So I explained, multiple times, but right here, in order to play this game, right, you go to AWS Skill Builder, you sign up. For the Solutions Architect role, it does cost a little bit of money, right, per month. So you can just sign up one time, pay it, play it, and then you can, do whatever you do after that. All right, so like this is our design diagram, right? So for those of y'all who are watching for the very first time, if you come here and you look at this and this looks like just a total foreign language, right? They have the option where you can look at these video concepts and it will explain the topics that you will go through throughout the exercise, right? All right, so here, this is our diagram here, all right? So in the first step, right, this solution uses Amazon Elastic Container Registry, Amazon ECR, right, Amazon ECS, and AWS Fargate to host containerized applications without the need to provision or manage servers, right? So you have Fargate right here. You create a task definition with ECS. You have AWS Cloud 9. That's your interactive IDE, interactive development environment in the cloud. Don't worry, we're going to get to that, right? You create a Docker image, right? This is your containerization image. You create this image first, all right? Then you will push that image to ECR, which is Amazon's, like AWS's repository. So if you use Docker just straight up, you're going to use Docker Hub, right? Or that you have GitHub, right? You can push images to these various places, but Amazon has their own one, and it's called Amazon ECR, which is Elastic Container Registry. So I just go through this fairly quickly. All right, so use Cloud9 integrated development environment to create a Docker image of your application. All right, to create the Docker image, you must create a file called a Dockerfile. Notice how it's caps, that's very important. A Dockerfile is a manifest that describes the base image you use for your Docker image and what you want to install and run on it. Use the Docker build command to build Docker images from the Dockerfile and context. A build's context is the set of files for the containerized application located in a specified path or URL. Man, I'm familiar with this stuff, and I don't even know what that means. All right, so look, Amazon ECR is an AWS managed container images registry service that is secure, scalable, and reliable. Yes, you can store, share, and deploy your container software anywhere. After the Docker image is created, push your container image to an Amazon ECR repository. We're going to push with that push command in Docker, right? All right, a task definition, right? So a task definition is like a blueprint in ECS. This is how you tell ECS what to build for you, right? So a task definition is required to run Docker containers in Amazon ECS. A task definition specifies parameters such as CPU and memory to use with each task launch type, right? Whether you're going to use EC2 or Fargate as your launch type, what type of machines or what type of servers do you want to use? You use your networking mode, host bridge, AWS VPC. Login configuration, where do you want to send your log files to, right? The run command, data volume, and IAM roles that you will use for your tasks. Don't worry about it. Let's keep going. All right, so Amazon ECS is a highly scalable Docker container management service that helps you run and manage distributed applications that run in your Docker containers. An Amazon ECS cluster is a logical grouping of tasks or services running on Amazon Elastic Cloud Compute EC2 instances, right? A task is an instantiation of a task definition within a cluster, right? If you want to maintain a desired number of tasks simultaneously in a cluster, you use Amazon ECS. AWS Fargate is a technology that you can use with Amazon ECS to run containers without having to manage servers or clusters or EC2 instances. Now, the reason why you would use serverless, right, is because if you build and maintain web servers, you're going to have to be responsible for the operating system. You have to be responsible for patching, security, right, updating, all that type of stuff, right? If you run the serverless option, which would be like Fargate, then AWS would take care of that for you. So just always remember when you hear the term serverless, it means that that's less administrative overhead that you have to use when you can just use the AWS service, right? All right, Fargate is a quick way to launch and run containers on AWS. Customers that want greater control of their EC2 instances to support compliance and governance requirement or broader customization options, you can choose to use Amazon ECS without Fargate. All right, Amazon ECS uses containers provisioned by Fargate to automatically scale, load, balance, and manage scheduling of your containers for availability, providing a streamlined way to build and operate containerized applications. You can run your Amazon ECS task on Fargate to deploy and access your containerized applications. To deploy and access a second containerized application, create a new Docker image, create a task definition, and run a new task in the Amazon ECS cluster. Now let's go over to our plan, right? So what are we going to actually do today, right? So for this practice lab, this is the guided portion of our exercise, right? Step-by-step guided learning. Create a Docker image for an application, create an Amazon ECR repository, and then push the Docker image to it. Deploy an application with Amazon ECS and AWS Fargate by using an image from Amazon ECR. And then in the do it yourself section, you want to deploy a second application, my-second-app, in Fargate by using the image from Amazon ECR. Validate access to the second application. That's what you're going to have to do at the end, right? So now let's go ahead and go to our practice. And this is our practice step. So this is when we're going to actually start going into the cloud, right? So the first thing when you come into these videos, right, you want to go ahead and click Start Lab, because we never know how long it's going to take the revision. This one did real quick, right? The second step, you always want to look for any associated lab files, right? So right here we have our lab files. We have our zip file, so we'll go ahead and download this guy, come over to our downloaders. Now, if this is the first time that you're watching this exercise, and you're using a Windows computer like I am right now, and you don't have a zip file, then you need to go to your, you don't have like an extractor, then you can go to like your, Microsoft Store, and then you can go to like the Microsoft Store and then you can go to like the Microsoft Store, and then you can just download an application called 7-Zip, and then you can unzip it like that if you're using Windows, right? And if you're using Linux, then you just type in the command and it will extract all the files. Outstanding. All right, now, so we have our associated files. Now let's go ahead and open up our AWS console, right? And voila, here we are inside of the cloud where the magic happens, okay? Now, first step's pretty explanatory. We just opened that up. All right, then we just downloaded that, so we can go past that. All right, so the first thing we want to do is open up our IDE, right? So Cloud9. So what we want to do, this is just another service, right? So what we want to do is we want to come over here to our console. We can search. Two different ways to do it. You can search right there, or you can just go to the search bar, just type in Cloud9, right? And then this IDE will come up. If you want to save it as a favorite, you can do so right there. Okay, so now this is our Cloud9 instance that has already been created for us, I believe. So now let me go ahead and open up that guy, and it should take a couple seconds to open that up. All right, so now let's go ahead and go past that. Let's go past, we just did that, we just did that. Let's go past that. All right, so now we come here to the Welcome tab, and then we're gonna choose, it looks like AWS Cloud9 dark gray theme. Okay, so we're still waiting on our instance to come here, so now we can read the concept behind this, right? We chose the, let me see. So we come here, step one, Welcome tab, yep. And this, in the Configure AWS Cloud9 section, on the main theme drop-down menu, choose a theme that you like. We choose the AWS Cloud9 Flatlight theme for the screenshot examples, right? Then go to the next step. So the concept behind this is using AWS Cloud9, you can choose from a variety of color schemes that control the syntax highlighting and the UI, the user interface. You can also fully customize the AWS Cloud9 UI by editing your style sheet. All right, got it. All right, cool. So now we have our instance up here, right? So now we can come down here, and it looks like the editor, what was it? The main theme, they chose dark gray. So now we have the dark gray. Now we have the dark gray theme going on here. Okay, good. All right, so now we've done that. Let's go to the next step. File, and then we want to upload the local file, right? So we'll go ahead and do that. So we'll come here to File, and then we will upload, or we can open. Come back to our environment. We'll go File, Upload Local File, right? Now here we can drag and drop our file, or we can just select File, right? So we go back to our download folders, and that's our lab code right there. All right, so we should be good to go. I see the lab code here. That's good. All right, so now, let me see, upload local files, go to the next step, upload files, which we did. Okay, now we open up a new tab here, and then we want to go to new terminal. So we want to open up a new terminal here. So we just did that. Now we open up a new terminal. We can close this out. All right, so now we have our new terminal here, and you see we're in the home directory of the environment. All right, got it. So now we will click on the next tab. All right, cool. So the first command, what we want to do is we want to unzip our files, okay? So we can just type in unzip lab code. For some reason, let me see. Like every time I do these videos, man, like for some reason it does not let me copy and paste. So I'm going to try and attempt to copy and paste. If not, I'm gonna have to type it out. So now let me see. Okay, good. So unzip lab code zip, right? And it's in this folder, so that's what it's doing right now. It's unzipping everything. And now, as you can see, since it unzipped it, you have your first app stuff here, install script, and then you have the stuff for your second app right here. Okay, cool. All right. Now, the concept behind this is AWS Cloud 9 provides a terminal that has full super user sudo privileges to manage an Amazon Elastic Cloud Compute instance, right? You can use it to run commands such as pushing code changes to Git, right? Compiling your code, right? Which is what we're going to do in later steps, I believe, right? Or displaying command output from your servers, right? All right. So now the next command, what you're going to do is install scripts. All right, install Docker. So this right here is an executable, right? So like if you was using Windows, you know, you would see a .exe and then you would right click and say run as. In Linux, it works a little differently, right? So in Linux, to run an executable, you need to have this / right here, and then you need to make sure that the file is a .sh, right? Shell script, right? So here we go. So now let's see if we can copy this. Okay, I'm just gonna copy this, and I'm gonna try to paste this as well. I did a Control-C because I'm using Windows, right? And then now, let me see if I can go ahead and run that script. All right, cool. Run that executable, great. So all that's taken care of. All right, so now we have that. And then the concept is Docker packages software into standardized units called containers that have everything the software needs to run, including libraries, system tools, code, and runtime. You can use Docker to build, test, and deploy applications very quickly. All right. So now, this is the good thing about using the IDE, right? So you can kind of see, like, you know, when you use regular Linux instances, you kind of have to know the commands and know your way around the terminal. When you use an IDE, you can kind of see what's going on. So right here, you see all these folders. That's kind of like that Windows format on the side. Kind of helps you keep track of things, right? So that's a good thing about that as well. All right, so first thing we're going to do is click on first app, and then we're going to click on this Dockerfile to open the Dockerfile, and then we're going to review it, okay? So let's go ahead and do that. So we're going to click on, what was that, first app? Let me double check and make sure. Yep, first app and then Dockerfile. So we click on first app, we can double click on Dockerfile, and then it's going to open up a Dockerfile. So if you've never seen a Dockerfile before, right, this is how Docker works. I'm not going to go too far in depth. I don't want to lose anybody, right? We want to keep everybody here. So, but just remember, so a Dockerfile, right, you know, it comes in a specific format, you know, just like HTML, right? Like the first line will always be exclamation doc type, whatever, right? So here for a Dockerfile, the first line is always from, and from is that's where you declare the actual image that you're going to use for your container, right? Now notice when you see these words over here in the blue, just remember when you're working with Docker, like all these different sections to build out your Dockerfile, they must all be capitalized in all caps. All right, so just remember that part. That's all you got to remember just for that. And from is where you declare your image, right? You have different sections: copy, your work directory. That's very, very important because you have to know what directory that you're working in, right? Then run. So what I would say, like whenever you run an image, you know, there's certain dependencies that go along with it. Now this, I can see this is a Python image, right? So you must do the pip install when you do the Python image, right? Like if you was doing Nginx, you would have to run the dependency in npm, right? And you have to run that. And then these are the associated commands that come with it that you're going to run while everything is building, right? So you have Python 3-m, and you have Flask, right? Like Flask is just like another kind of like application that kind of works with Python, right? Like developers use it to like build things in the background and stuff like that. All right, then run, host, NEIP -- and then the port number is going to be 8443. So it's always, you know, you have to remember that port 8443, right? Because that's going to be the port that your containerized application is using. All right, so let's keep going. All right, so review everything. We just did that. I'll keep going here. All right, so now we have to, okay, so what we're going to do right now, right? So this is inside of Bash, okay? So what we're doing here is we're going to be setting environment variables. This is what this looks like to me, right? Just a disclaimer, I don't ever rehearse these videos. I just go through and do them live. So right here, right, we have like, this is what you call like environment variables, right? Now, what's the purpose of environment variables? So environment variables, right, is like you can use this, like let's say this is like a command. You use these commands so you have a region, right? Because you know you have different AWS regions. So in AWS configure, you say AWS configure get region. So just by you typing in this command, every time you use that, every time you use this in the future, your region will already pop up, right? So we're going to declare the region as US East 1. Then we're going to talk about the repo name. So we're building a repo name here, right? So the repo name is going to be my app. So from now on, we will never have to type in, like, let's say it was my app followed by 1,000 characters. We wouldn't have to type that in. It would just be my app. So the purpose of the environment variables, right, it's just for like when you are, when you have services and other like code bases, right? You can use these little names and then the code can reference that name and pull up all the information. Let me show you what I'm talking about right quick. For instance, right, you see right here where it says account. If you say account, right, and then AWS STS get caller identity, right, -- query account -- output text. So if I came over here, like, let me go back to the terminal real quick. This is the Bash terminal. And what I'm going to do, I'm going to type in clear X right here, right? So I'm going to type in clear X. That just brings all the text back up to the screen. Now, the reason why I did clear X, because I don't want to just get rid of it. I just want to get it off the screen. If I just type clear, it would just disappear, right? So now, if I did that command that I showed you earlier, right? AWS STS get caller identity, right? Now, if I did this right, let me see if it pulls up. It might not do it because of the gameism. Oh, it did it. So if I just did this command, right? Now, this is all the information associated with this command. Nobody's gonna, you don't wanna type this stuff over and over again, right? So what you're doing is you're creating this environment variable. Where did it go? No, right here, I'm sorry. You're creating this environment variable so that way the system pulls this information every single time. You don't have to keep on typing this command. That's the whole purpose behind it, right? All right, then you have the full name, account.docker.ecr.region. Okay, that looks like just the name of a repository, and then the tag is latest. Okay, got it. So now we're going to go through and we're going to run these commands. So we'll just copy and paste, and we're setting these environment variables. That's the purpose of what we're doing here right now, okay? So go back to my terminal, and we are setting these environment variables, okay? So, and then when you set the environment variable, nothing's gonna happen. That's a good thing, right? So we'll check it at the end. I'm pretty sure there might be a section where we can check them. So here we go. So then you have region, and you just check it with an echo, right? So you just echo what you just typed. Okay, so then you have a region here. All right, so to create, so now we're gonna create a repository, right? Like we're gonna create this folder in ECR, Elastic Container Registry, just like you would do in GitHub, just like you would do in Docker Hub, we're gonna do in ECR, which is Elastic Container Registry, okay? All right, so now, what was the last command? To create a repository name, run the following command one at a time. So we're gonna create the command of my app, that's gonna be our repo name. So now let me come back over, do that. Okay, good to go. Now we're going to set the environment variable for our account, right? So we're going to put that there. All right, cool. All right, now we're going to set the environment variable for our ECR, right? For our image, repository, repo. All right, and then here it's kind of just telling you like, hey, you are setting the variables repo name for account, full name, and the previous commands. Go to the next step. Now, if you want to check and see like, hey, did these environment variables actually get created correctly, then you can just go in and you can copy and paste each one of these. Let me see. I might just have to type it out. So let's do echo $account, right? So if I came over here and I just said echo $account. All right, bam, and then it gives me my account information, and you see it is the exact account information that is right here. So that's the whole purpose of setting an environment variable, okay, in Bash, right? All right, so now let's go to the next step. All right, so to create an Amazon ECR repository, now run the following command. So now we're going to create a repository. So without us having to put in a whole bunch of information, our repository is already, our environment variable has already been set, right? So now let's go ahead and copy and paste this guy, right? Right here. Here we go. Bam. And all that stuff is being set right there. All right, to receive an authentication token, run the following command. So the following command is AWS ECR get login dash password dash region, right? Now, this is a disclaimer. Whenever you kind of log into these repositories, right, whether it be Docker or whatever, you're going to have to get some credentials to be able to do that. So that's what we're doing right now. All right, just so you know. So to retrieve our tokens, let's go ahead and copy and paste this guy right here. All right, cool. All right, and then the login is succeeded, like you see right there. All right, cool. And then the AWS CLI get login password command authenticates Docker to Amazon ECR registry. Now we want to go to the next step. Okay, cool. All right, so now what we want to do is, okay, so to create, build, tag Docker images locally, run the following commands one at a time. So here we go. So now we're about to run this command. So we're going to cd, all right, which means change directory. Now let's go ahead and do, let me do that real quick. There we go. I'm gonna do a clear -x again. Now let's do something real quick. All right, so you see we have different directories up there. So as you see the blue folders, right, those are all directories, or in Linux, a directory is a folder, right? So those are all folders. So whenever you run a Dockerfile, right, you see that the Dockerfile and all of its contents, right? This is like a child-parent relationship. So everything that's in the Dockerfile belongs to this folder called First App. Now, whenever you build a Dockerfile, you're building everything that's inside of that folder, and you can't build it from outside of the folder, if that makes sense. That's why we're going to run this command here, which is cd environment first app. You're just putting the path that you want to change directory to, and now we're going to the first app folder. So now that we're in the first app folder, right, you see this is just a representation. LS just means list, right? This is just a representation of everything that you see over here, right? It's all the same information, but now we're actually inside of that folder. Outstanding. All right, so now we're going to build, right? So this is the next command here, docker build. Let me go ahead and copy and paste, bring it over here. All right, so docker build -t, right? So now we're actually using Docker. You guys didn't even know that you're going to be using Docker. Isn't this cool, right? So now if anybody asks you, be like, yeah, I did it once or twice. Now, docker build -t means tag, because when you build an image, you need to tag it as well, right? And when we come to repo name, you see we've already built our environment variable right here, so everything is already in there. Now you see that period at the end, right? That period is very important, because what that period says, when you put that space in that period right there, that means, hey, I want you to build, right, the entire Dockerfile based on everything that's in this folder. We'll go ahead and do that. Now you see that our image is actually building, right? It's building. All right, cool. Step by step, everything's going good. Now you just gotta wait to make sure that everything gets built correctly. Like everything that's in that Dockerfile, from the image that's being downloaded, from the commands that we put in there, right? Everything is working and building. All right. Running pip as a user, we don't gotta worry about that. To update the pip, that's good with what we have. All right, so look, everything has been built successfully, and then it has been tagged my app -latest. That's how we know how to find it in the future, okay? Now we go to the next step. Okay, and then if we do Docker images, that's how you pull images up in Docker, -- filter reference equals my app. So we're gonna run this command. Now really, we don't really need to do this, because to be honest, there's only one image in here that's built, but if you had multiple images, yes, you would need to filter it, because you don't want to go through like, hundreds of images just trying to go through and find them. All right, so here we have, so in the repository, my app tag latest, the image ID is here, right? Created 56 seconds ago, 132 megabytes. OS, outstanding. All right, so now let's go to the next step. We reviewed the information. Yes, we did. All right, so now, right, now we're going to push an image, right, to our ECR, Elastic Container Registry, right? So we built the file locally on our machine. You can build it at your computer at home. You can build it on an EC2 instance in the cloud. It doesn't matter. So we built it locally. So now we're going to push it to our ECR repository. That's great, right? And you see, we already set the environment variables, repo name. We don't have to go looking for the name of our repository, all this type of stuff right here. So here we go. Let's go ahead and copy this guy right here. Let's do an old control paste. Okay, cool. All right, so now we've tagged it. So whenever you push an image to the repository, it must be tagged first. Now we can actually push it, right? So now let's do a Docker push, and then we have the full name, right, of the image. So here we go. Now let's go ahead and push that guy. Bam. And you see it's pushing, right? It's just pushing the image up to our repository. OS, outstanding. Everything went well. Got it, right? Let me do a clear and move everything back up to the top once again. All right, cool. So here we go. All right. And the concept behind this, okay, Amazon ECR is a managed AWS Docker registry service. You can use the Docker CLI to push, pull, and manage images in your Amazon ECR repositories. OS, outstanding. All right, now to compile, the next step, step 17, okay, to compile and push the image of the second app to Amazon ECR, run the following commands one at a time. So now we're going to cd change directory into install scripts, and then I'm going to show it to you really quick here. All right. Let me do a control. Yep. All right, cool. So then right now, at first we were in this first folder here, which is first app. We'll go ahead and close that just so you can get the dramatic effect. Now we're going to cd, meaning change directory, into this folder, right? Now notice you see the name right here, first app. Let's go ahead and copy and paste. Bam. And now you see that's changed, and now we're just working in that other folder, because remember I said earlier, if you build a Dockerfile, you must be in the folder where all the files of the application are located, right? Okay, cool. So now, and then we want to push, we're running the shell script of push second app. Remember, you must have that // in order to do so, right? So here we go. All right, bam. So we're waiting on that to take effect. Everything is good. Succeeded. Everything's building. Yep, and now it is pushing to our repository. Everything's going good. Everything's going good. If you have not done so already, please like, subscribe, all that good stuff. All right, so now let's go. We got a one here, review. All right, we reviewed it. Now we're going to go into our ECR, right? We're going to go into our container registry. So you can type, like right here, it tells you, hey, you can type in Elastic Container Registry. You can type in registry right here. Me, I do this all the time. So I'm just going to type in ECR, right? And then here we go. And then if you want to save it for future reference, you can do so, right? It's not a problem. All right, bam. Now we are in our private repository. So you see here, you got private repositories, private registries, sorry, and you have public registries. Or if you want to list them all out, right? Same thing here, private, public, right? Nothing's in the public, everything's in the private. These are our two repository names, right? So imagine these as two folders as well, okay? Where our images live. So this is our actual image here for my app. I don't want to get ahead of myself, so let me go back, and now let's continue to follow the game, right? So Elastic Container Registry is here. Got it. Registries. Click on My App. So that's what we'll do. We'll click on My App. All right. So that's our image, and the image tag is latest. You can have whatever image tag you want to. That's just the latest. That just lets you know, hey, that's the latest image that was pushed, right? All right, cool. So we did that. We clicked on that. All right. We want to copy the URI, right? Excuse me. So we'll copy, this is my app, we will copy this URI. So what I'm gonna do is off screen, I'm gonna paste this off screen to just a text document, right? And I'll show you real quick so when I mention it in the future, you know. So all I did was just copy that URI to a text document, and I did it off screen so I can use it for future reference, okay? And this is the My App repository, outstanding. So now, let's go to VPC, which is Virtual Private Cloud. So now I can just type in VPC here, and we're off to Virtual Private Cloud. Okay, so in the search, type VPC, go to the next step, right? Yep. Okay, now we want to click on your VPCs, and then this is the actual VPC that you're working with. So the name of it is going to be LabStack / Lab VPC, right? So we can click on your VPC. You can do it here or you can do it here. So we'll do it here. This is our LabStack VPC. And then as you can see, right, the VPC number is different than the one that's in the game, but don't worry about it. This is your personal environment. All you need to do is just know what is named, and this is the name of it right here. All right. So left navigation. All right. In your VPC section under VPC ID, select this. copy the ID for the lab VPC, and then paste it to your text editor. All right, so we're going to copy the VPC ID because we're probably going to need it for something, right? And then we will paste it into our text editor. Let me put this my app too so I don't get confused later. All right, so then, and then all I did just to show people off screen, because that ECR repository name was my app, and I have two, right? And Uncle Trey, getting a little, so just so I don't forget, I just named it myself. That's like a tag I just put right there, right? Outstanding. All right, cool. So now, right, let's go to the next step. Let's do it. All right, so we got security groups, right? So number one, click on security groups. And then number two, review the VPC of that security group, the default security group. Got it. So how do you find security groups here? There's no security group. This is the VPC dashboard. Oh, no, it's right here too. Thought we had to go to EC2. All right, cool. So we have the default security group. Let me bring this guy down just a tad. Let me see something real quick. Yep, VPC security groups. All right, so the default. So there's two default security groups here. Security group ID. Let me see which one we're talking about here. Because I see we have two. One permission entry. Let me see something real quick. Let me just check to make sure they're both the same. Now they are the default ones. Inbound rules. That's okay, this is a security group for that one. So, all right, got it. So both of them are pretty much the same, right? They just go to each other. So we're gonna use this security group. Let me double tap and make sure there's no difference here. All right, so in the left navigation pane, click security groups. In the security group section, review to ensure that the VPC ID that you just copied appears in the list of security groups. So that's what we were looking for. All right, so we're looking for that VPC ID. So the ID is, the last three is B1D. So B1D, that's what we're looking for. So it's actually this one here. Okay, got it. That's what we're looking for. All right. All right, so choose, let me see. So step two, the one you just copied. Yep. Step three, choose the checkbox to select the security group that has the VPC ID of the lab VPC. That's what we just did. Click the inbound rules tab, click edit inbound rules, and go to the next step. All right, so when we come to the inbound rules, we come here, and then we go to edit inbound rules, and then this is where we can add rules for our security groups. So remember, as we were talking earlier, security groups always provide security at the instance level. They control when traffic comes in, when traffic comes out. That's the whole purpose of security groups, right? All right, so now we want to, so it says, hey, inbound rules section, review the rules associated with the security group. So right now we have an all traffic, and for the source, it is this security group right here is the actual source. So we come here, we got all traffic, and then security group 534D is the source of our traffic. I'm just making a note of that. SG, what's that, 543D, okay. All right, got it. And then click delete. Oh, shoot, they want us to delete it. All right, so we're deleting it. So we deleted that rule. Now go to the next step. And now we want to add a rule. So we're going to add a rule custom TCP. And then we're going to put that port 8443. That's the same port that we had in our Dockerfile. So remember, I told you to remember that, because that would be the only reason why we would declare it there, right? And then we would choose all traffic, right? That's what all zeros means. It allows all traffic, goes anywhere, okay? So now let's do that real fast. Let me look at that. So custom TCP 8443, port range is 8443, all right? Then we got anywhere IPv4, and then all zeros right here. Outstanding. No description, so we're G to G. Good to go. All right, cool. So now, when we come back, Now we're going to go into ECS, which is Elastic Container Service, right? This is the containerization application that we would use to deploy everything to the cloud, right? We'll deploy and provide services for our end users. That's what we use that for. So then we come up here and we just type in ECS, or you can type in Elastic Container Service, whichever one you feel comfortable with. And then we can come over here, and they already have a cluster provided for us, which is lab cluster. So we'll just follow the steps. Review lab cluster, yep. All right, and then click on task definitions and then create task definition, right? So task definitions are the blueprint, remember, right? That's how you kind of build out, declare everything that you want to your cluster, like the attributes of your cluster, right? So the concept is, hey, using tasks, you can define a set of containers that you would like to be placed together, all right? Or part of the same placement decision. Define their properties, right? Define how they will be linked. Tasks include all the information that Amazon ECS needs to make the placement decisions, right? So let's go to task definition, right? Come down here to the lower left. We're going to create new task definition, okay? And then we'll go to the next step. So the name is going to be first app, all right? That's going to be our task definition family. First app, there we go. Notice the capitalization of the A, right? So then our launch type is going to be AWS Fargate. So instead of us, being able to manage our instances, we're going to do it where we utilize like the serverless function, right? Where everything's taken care of in the background. So step 2 in the infrastructure requirements section for launch type, review that AWS Fargate is selected. For operating system architecture review, Linux-8664 is selected here. All right, scroll down to task size, go to the next step. So we're going Fargate here, and then Linux-86-64. All right, cool. All right, then we want to use 0.5 vCPU and then 1 gig of memory. All right, that's what we're declaring within our task size. So we come here, 0.5 vCPU and then 1 gig of memory, okay? Then we're going to scroll down. All right, so we got my app here, and then we're going to use the URI from my app, right? Okay, so when we come down here in the container details, so we got, click on the name, my app, container details, my-app, yep, and then the URI, okay? So there we go. So when we do container details, we do, dash app? My underscore app. So my underscore app. Then we'll take the URI from our repository, right? Let me copy and paste this dude here. All right, cool. And then we're going to declare this as an essential container, it looks like, right? Yep. All right, good. And then container port 443 TCP, right? So we'll come here, container port is that 443 or 8443? 8443, yes. All right, so 8443 is going to be our container port, right, for our port mappings. TCP, we double check, make sure everything is good. Yep, TCP, got it. And then we're going to scroll down, okay? So these are just, we're defining the parameters of our task definition right here. Seems like I missed something. So we want to use log collection. We do want to use log collection, right? So we have that box checked right there. So we have a log groups, logs, regions, log stream prefix, and this is going to create like our CloudWatch logs. You see right here going to Amazon CloudWatch. All right. Oh, it says clear, so they don't want that. Okay, got it. So we don't want to use logs in this scenario. All right, so scroll down. And then right here it says create. I do want to see if I forgot. Storage, create. Let me just check this. Let me review this one more time. So we got Fargate here, because we didn't choose any task roles. These are necessary for our application. But let me just play the game and see what they're going to say. All right, cool. So we go here to create, and then we come here, and then we say create. So first dash app is created here. Oh, so task execution role is ECS task execution role. Probably because I didn't declare one, it created one for me. Okay, gotcha. All right, too easy. So then review, well, first, where's number one? All right, so here you have this big green box. I've told you all on many videos, right? If you see green, that means it's good. If you see red, that means it's bad, it didn't work. And if you see blue, that is just informational, right? All right, so then, let me see. We want to run, so we come to number one. Number two, review, the status is active. Yes, it is active, outstanding. So now you come to three, and then we want to do run task, and that's what we want to choose. So you have the deploy section right here. We're going to go to run task, right? Executing existing cluster is lab cluster. I don't want to get ahead of the game, so let me come over here. All right, we choose lab cluster. Then we choose launch type. We're not going to declare a capacity provider strategy. Choose launch type. And then we're going to choose Fargate. So we want our launch type, like I said, like I mentioned earlier, we want that to be serverless, right? You can do external, meaning this will be like on premises, right? Or you can do EC2 on cloud, or you can do Fargate, which would be serverless, okay? All right, and then scroll down to the bottom, task, and then first app and latest. That's what we want to do, desired task one. So then we scroll down, we have task, first app, latest, and we only want one desired task to run right now. Let's go to the next one. For our VPC, so we want to use our lab stack VPC. So this is networking, right? So this is the default VPC here. It's not what we want to use. We want to use our lab stack VPC. And then we have the subnets are auto-populated right here. Outstanding. All right, so lab stack VPC. And then, let me see, number two, for subnets, choose the subnet name that contains public subnet 1. So that means we can get rid of the other one. So this is public subnet 2, so we can go ahead and get rid of that one. And then we have the public subnet 1 right here. Outstanding. All right, use an existing security group. And then we're just going to use the default one, it looks like. So use an existing security group and default, yep, that's that. All right, cool. And then turn on, this is very, very, all right, so always make sure that you turn on whether to assign a public IP to the task ENI, Elastic Network Interface. Please make sure that that's turned on if you are using a public subnet, okay? All right, and then we scroll down to the bottom. Here we go. So it looks like, then we'll do create. We will choose for task overrides, we would choose the ECS task execution role for both. Really wouldn't do that in real life, but we'll just play the game. All right, cool, there we go. All right, and then we click on create. So bam, so now we have our task. It is currently provisioning, and we will always want our task to hit a desired state of running. See what the game has to say. Yep, we got our green boxes. Always looking for green. Yep. Okay, so now click on refresh and review. And like I mentioned, so we want the latest status to be running and then desired status to be running, right? So when we come down here, you can just click on this box, let it refresh. So now our status is running, but we also want that desired status, right, to be running. So now on the task tab on the last review to ensure that the status changed from provisioning to running. Under task, click on the task ID and then go to the next step. All right, so now we'll go over to the task ID. This is the task ID, is very long. All right, so this is the one you're gonna click on right here. Oh, hopefully y'all can see that off screen. I wanna make sure. Something real quick. Y'all should be able to see that. Let me get rid of this real fast. Oh shit. I done cut. Hold up now. All right, good. I was trying to get rid of my camera. All right, there we go. All right, so you want to click on the task ID at the bottom, right? Then that brings up our task. So here we go. So let me see, click, got it, clicked on task ID, got it. Last status is running, and the desired status should be running here pretty soon. All right, so let me turn that back on real quick. All right, cool, the camera's back on. And I believe y'all should be able to see everything. Hopefully you can see like the bottom of the screen and everything like that. All right. So let me see. In the configuration section on the public IP, click on the copy icon, copy the IP address, all right, for the configuration. So we want to copy in this configuration right here, we want to copy this public IP address and then go to the next step. All right, so then it says, hey, we want to copy that IP address and then make sure that you put colon and then that port number, right, so you can access it. So now let me copy that. Let me do a colon. The port was 8443. And bam, okay, so our application, right, is successful. Congratulations. This is your first containerized app. Hip, hip, hooray for Trey and all of us, right? All right, so now let's go to the next step. All right, cool. So now we've come to the, says congratulations, you completed the practice session. Go to the DIY section. So now we're in the DIY section, okay? So now deploy a second application, my second app in Fargate by using the image from ECR. Validate access to the second application. So now we want to create a second application. Okay. So now let's go back to ECR. Yep. And grab the URI for my second app. Okay, so I'll go back there. I'll grab the URI for my second app. I'll paste it off screen, right? Just like I did for that first one. Now we want to go back to ECS. Yep. Go to ECS. Let me read this one more time. Deploy a second application in Fargate by using image from Amazon ECR. Okay, got you. So now we go back to our cluster. Deploy a second application. All right, cool. So now let me come here to tasks. And do I need to do create a new task definition? Just to call this my second app. Yep. All right, whatever. Fargate, got it. We're good. Make that the same size. I can't. Oh yeah, 1 gig. Yep. Container details. We'll call this my second app. The image URI. So we'll grab the image URI from my second app. Do a no on that guy. Okay. Port. Ooh. I don't know. Let me see. 8443. I shouldn't be able to do this again. I don't think that's correct. But now let's go here. Let's just see what the game says. At least one. I already have a essential container, but maybe, let me see. Okay. All right, cool. So now we have that. We come back here to our ECS. We go here. We go to our tasks. Then we want to run new tasks. Launch type. Yep. Platform. Normally, yeah, got it. Tasks. My second app, revision 1 task. Networking. will be the same. I probably can use the same public subnet. Existing security group will be default. Task overrides. Need to make sure I'll just use the same information here. Container overrides, didn't have none of that, and I'll just create. All right, so now I created a new task. Let's come back to our cluster. Let's see the task. And right now our task is provisioning. Let me pull this guy over here. So our second app task is provisioning, and now it went to the pending state. Now it's in the actual running states, right? So now let's click on that task, and let's grab the public IP. And that was the first app that we have running. So now let me do a control V. Let's do a colon. I believe it was 8443. All right, bam, you did it. This is your second containerized app. So now what we will do, let's go over here. Let's go over here, and now we got about it. So the task ID, we want to do the task, the second application URL. Okay, so the second application URL is that in 8443, and then the second application task ID. So let me just do let me come here, go back to my tasks. Where's my second? My second app is here. So the task ID, and the task ID was actually right there. All right, cool. So then I can just come here, do a copy and paste on this guy right here. Let me go ahead and validate this guy or gal. Doesn't matter. It's equal opportunity over here. You know what I'm saying? Hold up. The request URL has failed. Check the provided correct URL and that the task is in a running. Oh, task might not be in a running state. I said check the URL, but let me double tap, make sure that's that same public IP. Yeah, right here. Yep. So that's it. So do a control C. So that's the URL, and it's 8443. I don't believe I would need that. But the task ID, oh, that's what it is. That's what it is. Hold up. Because that's the whole ARN, not the task ID itself. All right, cool. Now let's see what happens. All right, bam. So, hey, you did it, right? You configured the second containerized app. Now return to the city and give the customer the great news. It's all about solving problems on, behalf of the customer. That's what we do, man. I don't know why I got my back turned to him, but okay. All right. So, hey, thank you so much. Choose your reward. I don't want to choose no hospital. I choose this one. It's like a rocket ship or something like that. All right, hey, congratulations to us. We did it. Hip, hip, hooray. All right, everything is good. So look, I hope everyone learned something today. If you learned something, please don't forget to click like, share it with somebody else. But containerization, it's a difficult learning curve, right? But when you actually understand what you're doing and why you're doing it, right, it can be that much more rewarding in the end, right? So please make sure that you join me in my next video, right, where I do another solution in the AWS Cloud Quest series for Solutions Architect. All right, y'all been very fun. Thank you and have a great day.